Hello viewers, welcome to the lecture series of number system. This is your tutor Keshav Agarwal, and today we are going to solve problems based on factors and series. So let's get started with the problem number 1. The number of factors in 3600. We have to find number of factors in 3600. So for that we first do the factorization for 3600, and it gives we get we get 2 to the power 4 into 3 square into 5 to the power 2. And recall that to find number of factors, what we do, we take the powers, add a 1 to them, and take the product. So the same thing we are going to do here. We take the powers 4 plus 1 into 2 plus 1 and 2 plus 1. All the powers are added 1 and we take the product, which gives us 45. So that's a question based on direct result, and we get option number B as correct answer here. Problem number 2. Find sum of all the factors of 19,600. So we have 19,600 here. We have to find sum of all the factors for this number. First of all, do the factorization. So when we do the factorization, we have 2 to the power 4 into 7 square into 5 square. So how many factors are there? 4 plus 1, 2 plus 1, 2 plus 1. So this gives us 45. The sum of factors. The sum of factors will be given by 2 to the power 5 minus 1 upon 2 minus 1 into 7 cube minus 1 upon 7 minus 1, 5 cube minus 1 upon 5 minus 1. And on simplification of these terms, we get 54777, and D is the correct answer. Find the number of prime factors in the product. So we are provided with the two numbers whose product is, we are asked to find a number of prime factors in that product. So let's first of all break them down to simpler terms so that we can discuss it easily. 30 can be written as 2 into 3 into 5, and 24 can be written as 2 into 2 into 3. So if we open the powers, we have 2 to the power 5 into 3 to the power 5, 5 to the power 5, 2 to the power 15 into 3 to the power 15. On further simplification, we have 2 to the power 20 into 3 to the power 10 into 5 to the power 20, 5 to the power 5. So prime factors will be given by 20 plus 10 plus 5. What we are doing here is we are adding the powers of these numbers. So 20 plus 10 plus 5, which gives us 35. So the correct option should be option number A, that is 35. Problem number 4. If n is equal to 3 to the power 14 plus 3 to the power 13 minus 12, then what is the largest prime factor of n? So we are provided with the number n, and we are interested in finding the largest prime factor of n. So n can be rewritten as 3 to the power 13 times of 3 plus 1 minus 3 into 4. Now, if we have a closer look, you have 12 common here. So that can be taken out, and you will be left with 3 to the power 12 minus 1. On simplification, using the property here, a square minus b square equal to a minus b, a plus b. If we use this identity here, so you will have 3 to the power 6 minus 1 into 3 to the power 6 plus 1. So which finally yields 12 into 728 into 730, and on further simplification you will have 73 as the largest prime factor of n. So option number D is correct here. Find the sum of the series 6 plus 8 plus 10 plus 12 plus 14 plus 40. So we are provided with a series and we are interested in finding the sum of that series. Since the difference between two consecutive terms of the given series is equal Therefore, the given series is in AP. If you are able to recall that if we are provided with any sequence or a series, if the common difference, or I should say in simple words, the difference between consecutive terms is constant, then we say the series is in AP, arithmetic progression. So the same thing is given to us here. So if you see from 6 to 10, there is an increment of 2. From 8 to 10, there is an increment of 2. Correct? From 10 to 12, there is an increment of 2. So one thing, here we are able to observe that from with each proceeding term, there is an increment of 2. So we can say that this series is in arithmetic progression, and the common difference is given by 2. So value of D is 2. We are interested in finding the sum, but before that we must collect all the variables that are required to find the sum. So let me just quickly tell you, to find the sum is given by n upon 2, 2 times a plus n minus 1 d. So here a represents the first term, n represents the nth term, and d represents the common difference. Now you know the value of d. Okay. Next thing you have to find is the last term is given to you 40. Okay. And next a is 6. That is very clear from the sequence given to you. A is 6, but n is not known to you. How many values or how long is the series? So how many terms are there? That is not known to you. That we have to compute. But how? To compute that, we are going to use the formula that is used to find the nth term. So that formula is given by an equal to a plus n minus 1 d. So here L is known to you, A is known to you, D is known to you, and N is not known. So now using this formula, you can easily compute the value of N. Let us quickly substitute the values. L is 40, A is 6, N is unknown, and D is 2. So on simplification of this equation, we get N equal to 18. Now, N is known to you, A is known to you, D is known to you. You can easily compute the sum. Let us quickly substitute the values. N upon A times A plus L. N is 18, A is 6, and L is 40. And on simplification, you will get 414. So therefore, the correct option should be option number A, that is 414. Let us move ahead to problem number 6. The sixth and 17th term of an arithmetic progression are 19 and 96. What is the 25th term? So let me write the problem for you. A16. A16 represents the 16th term. Okay. That is given to you is equal to 19. A17th term. Okay. A6th term is given to you, not 16. So A6 is given to you, that is 19, and A17 is given to you, that is 96. And we are interested in finding A25, that is 25th term of this sequence. How do you do that? So if you recall, we have a formula which gives nth term for a sequence, for a arithmetic progression. That is, that formula is an equal to a plus n minus 1 d. So that means if you want sixth term, it will be equal to a6 a plus 6 minus 1 d. That is what exactly written here. So a plus 5d equal to 19. Okay. And before that, right. So next thing, 17th term will be given to you by a17 plus a plus 17 minus 1 d, and that will be a plus 16d equal to 96. The question here arises, why I am doing this? Why am I not able to directly compute A25 directly using formula? if you look at the formula, A25 will be equal to A times A plus 25 minus 1 times of D. A is unknown to you, D is unknown to you. How you are going to do that? You first need the values of A and D, then only you will be able to find A25. And A6 and A17 is here to help you out. They will help you to find the value of A and D. Here you have two equation, equation number 1, equation number 2. And if you solve these equation, you will have the value of D first, that is D equal to 7. And now if you substitute the value of D in the equation number 1, that will give you the value of A, that is minus 16. Now we have A, we have N, we have D. All of the term are known other than A25. You can just simply put the values here. A25 is given by A plus 24D. A is minus 16 plus 24 times 7, and we get 152. Hence, the correct answer should be option number D, that is 150 for you. So, students, let's move ahead to question number 7. How many numbers between 100 and 200 are divisible by 3? So, let us check the solution. How do you do that? So if the sum of digits, so one thing we are going to recall here is if the sum of digits of given number is divisible by 3, then the number will be divisible by 3. So since 102 is the first term between 100 and 200, that is divisible by 3, and the next outcoming number will be 105, 108, 111, and the last number is 198, which is divisible by 3 between 100 and 200. Okay, so now you have a series. You have a series in which 102 is the first term, you have 105, and it goes till 198. And you can observe that when we are moving ahead, there is an increment of 3 numbers, which each term, okay? So this series is an arithmetic progression, okay? So now we have A equal to 102, D is 3, and the last term is 198. So all of these terms are known to you. What is unknown? The N is unknown. You don't know how many digits, how many numbers are there between 100 and 200, or I can say how long is this series? And that's what our question says. Find out how many numbers between 100 to 200 are divisible by 3. And we narrowed it down to finding the value of n for this series. So using the formula L equal to A plus n minus 1D, L is known to you, A is known to you, D is known to you. Just simply substitute the values and get the value of n, that will be 33. So the correct option here should be option number D, that is 33. Let us move ahead to problem number 8. The population of bacteria culture doubles in every 3 minutes. How many minutes will it take for the population to grow from 1000 to these many bacterias? So this is what the question asks. So let's see. Since the population of bacteria doubles in every 3 minutes, hence the population becomes 1000, 2000, 4000, 8000. This is how the sequence is going to progress. And we are interested in finding how many terms it take to reach 51200. So ratio between two consecutive terms is equal, hence the given series in geometric progression. If you observe that we are not adding 1000, we are doubling it. That means the common ratio is 2 here. A is 1000, L is this. Okay. So L is equal to A to the power, L equal to AR to the power n minus 1. That is nth term for you. So 512,000 is equal to 1,000 into 2 to the power n minus 1. And if you simplify this, you will have n equal to 10. So it takes 3 minutes between first term to second term. So total term is 10, hence the maximum time taken is 9 into 3, that is 27 minutes. So the option number B is correct. Problem number 9. So problem number 9 says that a lucky man finds 6 pots of gold coin. He count the coin in the first 4 pots to be 60, 30, 20 and 15 respectively. If there is definite progression, then what would be the number of gold coins in the next 2 pots? So there is a lucky man. He found 6 pots with gold coins. In the first pot, there was 60 coins. In the second pot, there were 30 coins. In the third pot, there were 20 coins. And in the fourth pot, there are 15 coins. So, question one more thing is mentioned in the question is that there is a definite progression, means there is a order, there is a sequence, there is a some symmetry in which the coins are available in the pots. So then what would be the number of coins in the next 2 pots? That is what we are interested in. So the given series is 60, 30, 20 and 15. So we reverse the term, and now the difference between two consecutive terms of the reverse series is equal. Therefore, the reverse series is in AP. Hence, the given series in HP. So the fifth term is given by T5 equal to A plus N minus 1 D. First term is 1 upon 60. The difference is 1 upon 60. And fifth term will be given by 1 upon 60 plus 5 minus 1 times of 1 upon 60. On simplification, you will have 1 upon 12. That means the fifth pot is going to have 12 coins. What about the sixth pot? So for the sixth pot, we do the same. And this time, instead of 5, we put 6. So that will be 1 upon 60 plus 6 minus 1 into 1 upon 60. And that will be 1 upon 60 plus 5 times of 1 upon 60. So on simplification, you will have 1 upon 10. So the sixth term of AP is 1 upon 10. Therefore, the sixth term of HP is 10. So the sixth pot will have 10 coins. So fifth pot has 12 and sixth pot has 10. So option number D is correct, 12 and 10. Let us now have a look at problem number 10. So in problem number 10, sum of n terms given by the series. So we are interested in finding a sum of n terms. So what will be the sum of n terms here? A series is given to us. So to do that, we simply choose the values of n. In these types of problem, putting the value of n in option, we can check the sum of given series. So there is a very fast and quick way to do such kind of question. That is hit and trial. You check each and every option by substituting the values of n, and whichever works out is your final answer. So if n equal to 1, the sum is 1 upon 2. If n equal to 2, the sum is 5 upon 4. And according to this, now put n equal to 1 and 2 in each of the options and observe that which of the options satisfy this condition. The sum equal to 1 by 2 and sum for n equal to 2, it yields 5 by 4. And you will find that option number C is only the one option that successfully do what we want. So option number C is correct. So problem number 11. If a to the power n plus b to the power n upon a to the power n minus 1 plus b to the power n minus 1 is arithmetic mean between a and b, then what is the value of n? So putting the value of 1 in the place of n, we get a plus b by 2, which is arithmetic mean, if you remember. So option number D is correct. A ball is dropped from a height of 100 meters. So it's a long question. Grab all of your attention and let's try to understand the question very carefully. A ball is dropped from a height of 100 meters. The ball, after each bounce, rises vertically by half of its previous height. This means at the first bounce, it rises by 50 meter, by 25 meter in the second bounce, and so on. What is the vertical distance traveled by the ball between first and fifth bounce? That means, suppose this is a building, this is a building. Here you are standing, and this is a 100-meter tall building. Okay, and you drop the ball, and the ball is going to fall down definitely. Sir Isaac Newton said there is a gravitational force that attracts the body down towards the earth. So that is your earth. So this is definitely going to fall down. Okay. And when it falls down from the height of 100 meters, it says that it bounces back to the half of the previous. So it traveled 100 meters and it will bounce back till this. Okay. So it goes here, that is 50 meters, and it will come back 50 meters. Okay. Now the ball is again bounce back to 25 meters and again come back to 25 meters. So that's how the ball is bouncing and the height is continuously reducing with each bounce. So we are asked to find the vertical distance between the distance traveled by the ball between first and fifth bounce. Okay. So let's see. So total distance traveled by the ball is 50 plus 50. So according to the first, when the ball was dropped, it went to the ground. Okay, this is Earth. It reached the ground and it went after first bounce. We are not talking about the distance traveled by the ball when the ball was dropped. No, the question clearly says we are interested after the first and the fifth bounce. So between the first bounce and the fifth bounce. So this is the first bounce here. Okay, the ball fell down and it will go till 50, 50 meters. It will again travel back 50 meters, correct? So that's 50 plus 50. Now ball did its second bounce and it will go up till 25 meters, correct? And it will return back 25 meters. That is 25 plus 25. This was your third bounce here. After third bounce, it will go back 25 upon 2 meters. ठीक है? And it will come back 25 upon 2 meters. That's your 25 plus 25 by 2 plus 25 by 2. And it will have its fourth bounce and it will go back 25 by 4 and come back 25 by 4 and it will have its fifth bounce. So therefore you will have 50 plus 50 first bounce, 25 plus 25 second bounce, and this is third bounce, and this is fourth bounce for you. So if we simplify this, you will have 175 plus 25 by 2, and it will be 375 upon 2, which is option number C. Okay, let's move ahead. In problem number 13, if a ball is thrown from a height of 500 meter on the ground, the ball bounces 4 upon 5 times of its every last bounce. Find the total distance covered by the ball till it stops. This time we are not asked to find between specific bounces. It says when the ball was dropped, initially dropped, and when ball finally stopped at the ground, we have to calculate the vertical distance it traveled. Okay. So ball was initially dropped from the height of 500 meters. So this is a tower which is 500-meter tall. You are standing here and you dropped a ball. So it traveled all the way down towards the ground. Okay. And this is 500 meters and took its first bound and went upstairs. That will be 4 upon 5 into 500. Okay. Then it will And this happens twice because once it goes upstairs, that is 4 upon 5 into 500, and it returns back 4 upon 5 into 500, then again goes back. So that's the factor 2 here. And we took common because it is going to repeat each and every time the ball bounces. It comes down, goes up, comes down, goes up. Okay. So after the bounce, this bounce 4 upon 5 again reduces by 4 upon 5, again reduces by 4 upon 5. It will go till infinity. So if I take common and simplify it, this thing looks like a infinite GP, and we know the sum of an infinite GP. So we apply the formula for infinite GP here. That will be 500 plus 2 times of 400 upon 1 minus 0.8, and on simplification you will get 4500. That is option number A, which is correct. The sum of 4 plus 44 plus 444 plus 4444 plus up to n terms. So to do that, what we are going to do here, in this we put the values of n in respective options and check the answer. If you put n equal to 1, then the sum would be 4. Correct? In option number C, putting values of n gives 4. So what you have to do here is, that is a hit and trial method. For n equal to 1, the sum is 4. And now check each and every option by substituting 1. And which of these options yields 4 as the answer? If there are more than one option that yields 4 as an answer for n equal to 1, you can check it for n equal to 2. So in that case, you will get your answer, and it will be option number C. Problem number 15. Harmonic mean and geometric mean of two numbers are 10 and 12 respectively. So 10 is your HM, 12 is your GM, and what is your AM? So now try to recall that we have discussed the relation between AM, GM and HM. That was AM is equal into HM is equal to GM square. So that's a very pretty simple question. Now you know HM, you know GM, just put the values and simplify. So you will get 144 upon 10, that would be 14.4. Hence, option D is correct. Okay, students. So that would be all for this lecture, and I do hope you understood the questions well. And see you in the next lecture. Till then, revise the concepts, solve the problems. Thank you very much.